Hey, everybody. Welcome to our third episode of the Industrial Strength Podcast. It's a podcast more focused on industrial fire departments and industrial hazmat response. And once again, my name is Randy. I'm a hazmat specialist, 17 years on an industrial fire department doing hazmat. And with me once again today are my co-hosts, Jeff and Steve.
I'm Steve, a hazmat technician with 3 years of experience on hazmat team and about 10 years of experience in the industrial side of things.
I'm Jeff. I'm a hazmat technician for 20 years in the fire service industry, with 10 of those being in the industrial side of things.
Awesome. So today, we got a different kind of call we want to talk to you guys about. So the call started out, it was a Saturday in September. It's about 10 years ago. A call came into our dispatch center for an explosion in one of our production buildings. Initial reports noted that there was building damage to exterior walls and smoke coming from the building. So pretty serious call for us.
That's right. I mean, that's a danger that we think about every day on our site, but it's not too often that it happens.
Right. Thankfully.
Yeah. Now, the industrial fire department's hazmat team first arrived on scene and performed a first scene size up. The building is we'll call it 6-story tall building, even though it's labeled as 3 inside, just to meet codes of the area, with a type 1 construction, which is fire resistant, and was the newest of our site's production buildings. All the work centers had automation and the ability to remotely view tank temperatures, pressures, and valve positions within the building.
Right, yeah. And so I'm going to jump in real quick, talk about that type 1 construction. So once again, as we touched on in previous episodes, engineering controls are important to our site. And so this building, being one of our newest production buildings, they did type 1, which means that it's made of steel, right? So the structural members that make up the building can't burn. And in addition to that, they wrap those steel I-beams in fire-resistant concrete. So the only thing that's going to burn in this building are the building contents, not the structure itself.
Yeah, that's true, Randy. And this building was constructed with blowout walls and panels. And then on scene size up, it appeared that the panels on the Charlie Delta side of that third floor were actually blown out, and the exterior openings of the building near where the missing panels were blown out had almost a yellowish brownish discoloration on it. And there was no smoke showing from the exterior of the building at that time.
Now, there's no joke about those being blown out. You could see into the building from about a quarter mile away.
Yeah, that is true. The building fire suppression system was already activated, and it appeared that the building personnel had already evacuated from the building. Thankfully, the fire brigade and medical team arrived on scene. The chief from our industrial our department did take over the incident command on this.
Yeah, if I remember right, because of how big this was, being an explosion of a production building, we actually called in mutual aid, which is a rare occurrence for us. And so we had 2 different municipal fire departments show up on scene to assist us.
Now, correct me if I'm wrong, Randy, but isn't that probably the only time in our site's history that we've ever had to call in that many external departments for a single call?
Yes. So that's an interesting point. So this is, I think, the only time I can remember that we called in outside departments. There are other times that other departments are dispatched independently of us and show up for other things, mostly externally to our site on the border fence and stuff. But right, we called in 2 different departments for this. So this is the only time I can remember in my 17 years that no, we need the help. Come on in. So it was pretty serious.
That's right. Now, the sweeps of the building proved that the building had been evacuated and all the personnel were accounted for, which was another really, truly lucky incident for this case. We did remote checks of different production vessels, and it showed abnormal conditions in a piece of equipment called the Funda filter. This is a top of a filter located on the third floor of this building, while the body is actually associated and all the piping with it down on the second floor. So it's a pretty big vessel, actually.
Yeah, I think we got a image kind of what this thing looks like. So yeah, you can see on this image that the top of the filter, like the motor and the agitator and some of the top piping, would exist on that third floor, while most of the body and the outlet of this filter would be on that second floor. And this is very similar to a lot of our clarifying or sparkler filters, where you put your product through it and it pulls out solid waste out of it, right? This is something that we would use in different types and forms throughout production.
Yeah, at the time, of this event, the filter was drying out spent manganese dioxide that had been used in a process. So, Randy, you want to get some background on this information?
Yeah, I'd love to. So this is a unique process that was designed for our site. It was designed for use in the production plant back in the early 2000s. And part of that design, scope of design for this process, was when they were doing it on small scale, they sent out samples for safety testing. And this is, once again, like I've said many times before, our site prides ourselves on engineering controls and safety. We try and do a very good job with it. And so we sent out many samples for safety testing to make sure that things were done in a safe manner, look for hidden hazards. So tests were conducted specifically around drying conditions for this waste cake of spent manganese dioxide. And test results came back and found the potential for thermal runaway with this waste cake. What they found was that if they had a dirty cake, meaning like product in the cake and was unwashed, the thermal runaway occurred at a lower temperature and shorter time frames. But if they washed it with a process solvent like acetone, that the cleaner waste cake required a higher temperature and longer time to do before it hit thermal runaway and had a exothermic reaction. So, and what they did is the third-party testing that got paid for found that the maximum safe temperature for drying the cake under any condition, dirty or clean, should have been 53 degrees Celsius. And that temperatures above 53 degrees Celsius were shown to achieve thermal runaway within 3 hours. So, and that was with clean cake or dirty cake. So 3 hours at 53 or higher. And so, that was for us a serious concern, right? So it was one of those things that came up in safety testing. We wanted to make sure it was recognized. And so when that procedure was originally written, it got written for 35 degrees, right? So we wanted to try and make sure there was almost a 20-degree kind of buffer. So that way, if there was some weird process upset, it wouldn't have hit that temperature. So original records were written for 35-degree drying temperature. And what they're trying to do is they're trying to drive off the process solvent, which was acetone, to then package a dry waste cake for disposal. So that's kind of the background on how this process worked for that drying.
Now, if I remember right, didn't they make some typical site changes to try and increase productivity from what those initial studies showed, Randy?
Yeah. And so this is probably where we had failures. The fact that it was definitely, once again, hindsight's 2020, right? So we're always trying to improve what we do, right? And so a lot of times we have a specific group on site, and what they try and do is they try and either maximize output or reduce cycle time. And so one of the things that they did was they changed the procedure for the drying, right? Because 35 degrees Celsius, it was a long time to drive off all that acetone and get a dry cake. And so, unfortunately,
Randy, what I hear you saying is they want it dried faster.
Yeah.
So it's less time.
Yeah.
Which equals more money in their pockets, right? No.
I don't know about more.
Be the case.
Not more money, yes. Their pocket, I don't know. It's a nebulous question, but they wanted faster cycle times. Yeah, for sure. And so what happened was someone made a change to that record. They did an edit and they got it pushed through, and they changed the drying temperature from 35 to 55, which put that over that maximum safe temperature that we talked about just a couple minutes ago. So they tried to institute those changes so they could dry the acetone off the manganese dioxide cake quicker, so they could ship it off the waste. So reduce cycle time, be looked at as a savings. Everyone pats themselves on the back. But here's where it all kind of goes wrong. So that person who instituted that change wasn't part of the original planning for the process, and they weren't aware about the safety testing that had been done. So they had no idea about this thermal runaway problem. And so I don't know if that's an employee retention problem or the fact that our site encourages people to cycle through jobs at regular intervals, but the people associated with this process when it was put into place weren't the same people in charge of running it at that time. And so unfortunately the push to change that temperature went through and it got changed to 55. And that is really the root cause of our problem.
Hey, Steve, do you want to talk a little bit about the manganese dioxide?
Yeah, so let me nerd out on that, man.
Oh, that might be tough for me, but
you got this. You've been on that team for a while.
So, manganese dioxide is a naturally occurring mineral which is brown to blackish in color. It's a solid and it's completely insoluble in water. Now, manganese dioxide is used in dry cell batteries. It's used as a pigment, and it's also used in an oxidation or reduction reagent in organic synthesis, which is typically where we find it in our use on site. The manganese is absorbed mainly via ingestion, but it can also be inhaled, and it binds to parts.
It could blind it, but
let it get in your eyes, it'll blind you.
Sometimes it's just tough speaking around here. It binds to parts with blood plasma and is distributed to the brain throughout all other body tissues, though it tends to accumulate more in the liver, pancreas, and kidney. A lot like those toxins that a lot of us enjoy on a daily or weekly basis.
I don't know what you mean.
Really? Now, manganese is capable of existing in a number of oxidation states, which can influence tissue, toxic kinetic behavior, and possibly toxicity. Exposure to manganese dust, fumes, compounds should not exceed a ceiling value of 5 milligrams per cubic meter for even short periods, because this element's toxicity level is very high.
Yeah, that's not much.
Now, Jeff, what can inhaling manganese actually cause and some side effects for patients?
Inhaling it, especially the dust, it can cause diseases in the lungs. I mean, obviously you're breathing it in, so it's going to be the lungs, bronchitis, pneumonia, and even ingestion. Yeah, you're ingesting it, so the dust, the fumes, everything. It's really, really harmful, and it can cause irritation of the throat and gastrointestinal tract. Imagine where all that stuff's going to be going in your body, breathing, inhaling.
Right, yeah.
Swallowing.
I gotta imagine that pneumonia thing is probably like, when we all do CPR training, we're taught to be careful if someone throws up, because if you put it back in their lungs, they get the aspirational pneumonia. It's got to be the same way with this. Like any foreign body in the lungs is going to give them a pneumonia, but on top of it, this stuff's toxic too, right?
Oh, absolutely. A post-mortem of this incident did look at how there could have been, such a powerful explosion, but without seemingly any damage to the Funda filter.
Mm-hmm.
It was discovered that the elevated drying temperature had reduced the onset time of a runaway thermal reaction, and that, in fact, the thermal runaway had occurred, though.
Now, before we go too far into that, I think we should tell our listeners a little bit more about how our call progressed.
Yeah. So like one of the things I remember is that like after the initial call, after we got set up, and we figured out what piece of equipment was the problem, we wanted to kind of see what we were dealing with. And so first thing we did, life safety, right? Life safety is very important. So we confirmed that everyone was out of the building. And then when we went back to remote viewing that Funda filter, man, I remember that we were getting like crazy numbers. Like to us, you know, typically we try not to run something hotter than 120-ish degrees Celsius. But when we were getting like numbers off this filter, it was saying like 400 Celsius, which first thing I thought, I was like, that sensor's broke. You know, don't trust it. It's just
that's
it's an
a
error.
blazing hot temperature.
Yeah, but it was honestly what it was, right? It was rip roaring, and it had hit that full thermal runaway. And so I also remember one of the things that we had was we left those sprinklers running because we wanted to try and cool the exterior of this filter as much as we could. We were afraid of hitting it directly on the inside with water because we were afraid of it flashing off the steam and making a pressure explosion. But we kept the sprinklers on and let it kept running down the outside because we were afraid of it rupturing. So we were trying to cool it from the outside, at least keep it in check as best we could.
Absolutely.
So, really, what kind of action did we take on this? I mean, you have the offense, you have the defensive.
Yeah.
What kind of?
Well, we typically like to go offensive just because it's our nature around our site. But in this case, we took a defensive position, and we took this with routine temperature monitoring and pressure monitoring along the vessel, taken at regular intervals just to take a look at the temperature of the reduction and make sure that that reaction was no longer occurring. After many hours, and I do mean many hours.
Many
I
hours.
think you probably could say days.
That would be a more accurate statement. It was very close to days. The temperature within that Funda filter started to reduce to below 100 degrees Celsius. Not Fahrenheit, that's Celsius.
Mm-hmm.
So still pretty hot. Which was actually the point it was deemed safe to return to the building.
Yeah.
Yeah, really, that interior of that plane had black and brown staining really all on that third floor in and around, especially that Funda filter. And it was later discovered to be the manganese dioxide.
Was it really? Are we still sure about that?
I think it's pretty
I think
confident.
it may have been maybe the operators running away and leaving traces of them behind.
Stains as they're going.
To be clear, this might have been the first time that going to the bathroom ever saved someone's life. I mean, typically on our site, we take readings at vessels at a minimum of every hour on an interval. And on this particular day, the operator in charge of taking these readings went up about 5 minutes early of those hour reading marks just because he needed to go to the bathroom, so he was getting it out of the way early. He was actually on the can when this thing blew.
Dude,
so parts of those
lucky.
brown spots could be from him.
Yeah. Like I said, you're definitely right that this, taking the reading early is really what saved him, right? So it prevented a fatality on site. And it was just one of those things, happenstance, man. Pure dumb luck.
Yep.
Yeah, man. So when the temperature of that vessel did go below that 100 degrees Celsius, teams were sent in to inspect the interior of that Funda filter for any vessel ruptures, even line integrity and any other physical damage. There was no other physical damage found, surprisingly.
Yeah, because they're still trying to figure out how that thing blew, right? So how do we get the blowout walls blown off if it doesn't look like anything was damaged?
Yeah.
That's right.
Water was flushed through that Funda filter, especially to bring that internal temperature back to, I guess, an ideal room temperature. Yeah,
because once it was below 100, we weren't afraid about flashing it off to steam, so we could then just use copious amounts of water, just, like any good fire suppression, copious amounts of water to drive down the temperature.
Dilution.
Right, it worked in our favor.
Dilution is a solution.
Yeah.
So at that point, we actually turned off the sprinklers just because they weren't needed anymore.
Yeah. In a post-mortem of this incident, we, try and dissect what really happened, how we could have had that explosion, blowing out the blowout walls without a ton of damage, being physically there. We looked at, how that could have happened, and what we discovered was quite interesting. So obviously we knew that the drying temperature was elevated beyond, 53 maximum safety at 55. And so with that increased temperature, reduced the onset time of that runaway thermal reaction, and that we had that thermal runaway, right? So we had the external data, the remote sensing data showed us 400 degrees Celsius that it had hit thermal runaway. And that what happened was that acetone that was still remaining in that Funda filter was instantly vaporized, like almost instantly vaporized, and expanded its volume significantly by a factor of like several hundred times. And so,
now, Randy,
yeah.
What did we call that instance when that thing blew at the time?
Originally an explosion, then it became a blevy, and then that was too spicy, so we called it high energy release.
Now, for our viewers out there, can you explain what a blevy is? Because maybe not all of them know that.
Ooh, so blevy, it's
actually, let's go with what is the definition of, or the correct terminology of a blevy?
What are you looking for there, Jeff? Because I got a couple different answers.
It's an acronym, right? BLEVE.
It is.
So it's a boiling liquid elevated vapor explosion.
Evaporation vapor explosion.
Yeah. So
something.
Superheat gas or superheat a liquid, turn it to a vapor, introduce a spark, it goes boom.
Now,
that's layman terms for it. That's how we're getting there.
Now, was that even close enough to acceptable by legal department's terms?
Oh, no. I'm pretty sure they would have not acknowledged this ever happened at all.
So what did we come up with just to satisfy all those legal ramifications out there?
I don't remember, man. I think I stopped paying attention if they said blevy and they said no.
I believe they came up with something that sounded pretty scientific and to the outside world wouldn't really matter to most. And that was called a high energy release.
Yeah. We just called it a whoopsie. But yeah.
Now, to get back to the actual call, the superheated acetone gas was found to have stretched grade 8 hardened steel bolts by almost 2 inches. Now, for
That's
those
incredible.
of you out there who don't know, grade 8 hardened steel is the hardest steel out there. You can't bend that if you wanted to, even with the heaviest of machinery.
Right.
Now,
that's incredible.
No kidding.
Yeah.
These bolts actually held the lid of the filter right onto the body.
Yeah. So, that's exactly what happened. So, right, we never had any damage to the production vessel, but that's because once that acetone vaporized off, it created such a pressure head. It stretched out those bolts and created that opening for all that pressure to get out, that superheated acetone vapor. And then as soon as it exited the vessel, it mixed with oxygen because the interior of most of our vessels are inerted, including this one. So once it mixed with oxygen, it caught and it blew, right? So that's where that pressurized explosion wave came from. So, it's one of those things where it was highly unusual because that wouldn't even be the thing I thought would have failed, right? So we found that it was like it stretched to 2 inches, and I was amazed that we didn't have a sidewall failure of the vessel. I would have figured that's where it would have failed. It wouldn't have stretched out bolts by 2 inches. So to me, that's just insane.
I mean, we could have had valves go, anything. But really, the bolt is the smallest part on this damn thing. So I would have thought it would be the first to go.
Yeah. Yeah. So when the bolt stretched, like I said, it let the lid lift by 2 inches. Yeah. Exact measuring 2 inches.
If this is 6.
Geez, typical.
Oh, wait, sorry, 6.
Practicing my fishing skills for when it gets to be spring. 6 inches. But so when the stretch happened, man, that's when it let that acetone out, and then it took manganese dioxide with it from the interior of the vessel and kind of blew it across that floor. And that's how we got a bunch of staining throughout the building and out the blowout panels, the exterior of the building.
Yep. Now, with all that going on, how long did it actually take to get back to a normal state?
Man, it felt like it was like months and months, right? Because this was like a pretty serious thing. So it took a while to do the investigation. The environmental cleanup thing took a couple months on its own, just to bring in an environmental contractor and have them pressure wash everything, like on the second and third floors, to try and remove as much of the staining. And that's just the environmental cleanup. That's not like resetting the blast walls. And that's not, cleaning out the filter, restoring that, checking mechanical integrity. There's a lot of things that went into that. It was like months and months and months.
Several more months beyond just the cleaning.
Yeah.
Officially, to get everything back to normal for production's sake, it was 2 months. But to be clear, this was almost 10 years ago, and just a couple months ago, I was in that very same area, and there are sections of beams and stairwells that still haven't had the drywall replaced fully yet or recoated. So we're talking a multi-year incident.
Took the building from like type 1 to type 2, just knocking concrete off from high beams. But seriously, this is a good call, right? This is one of those things that was highly unusual. Unfortunately, it was one of those things. There was a change to try and improve a process to make it better and faster that really worked against us. And by a quirk of fate, man, it worked out that no one got hurt, and we were very, very lucky on this call. And there was very little we had to do from a hazmat side of things, right? It was mainly supportive, right? So as far as hazmat goes, we were just standing by. We had what decon ready for anyone went in the building, but there wasn't a lot of building entry, right? It was a lot of monitoring remotely defensive positions, and we just sat by. It was, from a call perspective, the incident was very interesting, a lot of excitement. The standing by waiting, very boring.
That's an understatement, but yeah. So share your thoughts, experiences, and requests for any future episodes, anything you want to talk about. You can reach out to us, hazmatharder@gmail.com.
Yeah, if anyone else had a whoopsie on their site and are willing to come talk with us about it, email us, let us know. We'd love to have you on. Yeah, so we'd love to swap stories.
So just a little bit of insight into our next episode, we plan on telling you about the history of our department. So we're going to go all the way back to inception and its evolution from full-time all the way to volunteer, and just the intricacies that we face on a daily basis.
And not only that, but how we got onto the teams, right? So a little personal history on us, that we get to know us better too. So,
absolutely.
Yeah. So thanks everybody for listening in. We appreciate your time and efforts. And remember, hazmat harder.
That's right.